In this video, we're going to look at linear regression as a forecasting technique. The whole point here with linear regression is that there's some kind of trend that's going on with our data that we're expecting to be able to hopefully tease out and see what this line really looks like. So let's go look over at our data. In this case, we have demand and month all set up here. For linear regression in Excel, it's what we're going to end up doing is we're going to insert just a line graph. Oh, sorry about that. Insert a scatter plot. Because when we insert our scatter plot here, we now have our data that we can kind of see, looking back at it. Data is kind of beginning to go up over time, but how much is it going up over time? If I left click on any one of the data points and then right click, I can go in and add a trend line. Okay, pops up a little dialog box over here for me. Format trend line, leave it as linear, don't try to do exponential or one of these others. It's not going to help you. Linear is easy to explain to your boss and the other things are not. Other things I want you to do on this is I want you to display the equation on the chart and I want you to display the R-squared value on here. Alright, we finished with those. I'm going to go ahead and close this down. What Excel has just done is it has taken a weighted difference between this data point and a line, this data point and a line, dot, 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 all the way across, and it's minimized the distance to it, creates a line going across through there, and then it gives us a linear equation like we're used to seeing where y is equal to the slope times x, y equals mx plus b, right? So this is the intercept. If we followed this back across all the way over here, we'd see that that would intercept at 13.6. There's our line. That line matters to us. The next thing that we want to look at is this R-squared value. R-squared value tells us what variance, okay, what variance that's happening on these lines is explained by what's happening over here. What variance is happening with month. As the month gets larger, what percent of that variance can you explain with what's happening with the values over here? From a forecasting technique, if you've got an R-squared value of more than 50%, you're in pretty good shape to go ahead and just use this equation. If you get a really low R-squared value, it may mean that there's a whole lot of jumping around that's going on in here that you can't explain, and you need to abandon the idea of linear regression. So R-squared above 50%, feel free to use it. Okay, so now our equation is y equals 1.1143 times x plus b, which is our intercept. How do we use that? Well, right now we're trying to forecast what's going to happen in month 7. Now x is the month. So if I go in here now and I type in equals 1.1143 times, we're looking once again for month 7, times 7, and then we're going to add to it our b value, which is 13.6. Our answer, and I guess I probably should have just gone ahead and wrote it in there so that it makes sense for us. Our forecast for month 7 is 21.40. All right, because we used the linear equation, 7 in place of the x to get to that point. Now the next one is what happens for the linear regression for month 10. I'm just going to go back here now. Instead of putting in 7 in that place, let's put in for month 10, hit enter, and there's our forecast for month 10. Hopefully this makes sense for linear regression. All of the other techniques that we've talked about before do not work well with a linear trend, whether it's increasing or decreasing. Linear regression is the only thing that can get you there to be able to figure out what's going to happen out here in the future so that you can do a better job of forecasting. Hopefully this makes sense and that you understand linear regression now.